What does it take to cut a ship into two halves? To strip down and reassemble a giant plane? To overhaul the world's longest high-speed train? It takes hundreds of professionals, expertise, precision, and courage.
It's never been done before.
Pushing everyone to the limit.
It is surely a challenging job.
Now on Mega Pit Stops. It is one of the fastest and most state-of-the-art trains in the world, the Russian Sapsan, in English, Peregrine Falcon. The base model of a Sapsan consists of 10 cars, offering space for up to 604 passengers. Its maximum speed, 250 kilometers an hour. Its technology is perfectly adapted to the Russian climate. Even at minus 40 degrees Celsius, all systems function without fail. One of a kind, a Peregrine Falcon is also capable of double heading, which means it can pull 20 cars, taking it to a proud length of 500 meters, the record for the longest high-speed train in the world. After 3.7 million kilometers, every Sapsan needs a mega pit stop. During what's called a R3 revision, engineers overhaul the entire train. To accomplish this within the 34 days they've been given, they have to separate it into two halves and work in parallel at two different stations. The most complex of all the processes involves lifting the train and removing and replacing the chassis. While this is going on, the other half of the train is repainted. They also have to replace the pantographs and overhaul the onboard electronics. Inside, all 604 seats will be checked and repaired. They will only be able to meet the delivery deadline if everything goes according to schedule. St. Petersburg, Russia, Metallostroy Train Depot. This workshop was built especially for maintaining the Sapsan. Dennis Sharamet is the project manager for the upcoming Mega Pit Stop.
Now it's getting tense. The train is arriving soon. A major revision is comprised of many different work steps, from cleaning to inspection. But the first important thing is running it in. That's when it all starts.
The Sapsan trains have been in operation since 2009. Today, the first train will arrive at the depot for the big R3 revision.
While running it in, it is very important to watch how the wheels rotate and how the bogies and fans are working. We can tell if there are any problems just by listening to it.
Damage that previously went undetected, and that, in the worst-case scenario, could seriously disrupt the tight schedule.
Here I can already see the first problems. Several windows are broken, probably from rocks that the train threw up while running.
A total of 10 windows are shattered. That means a whole day's worth of unscheduled work. Once the train is in position, the technicians start by disconnecting it from the overhead power line. Working with 3,000 volts would be too dangerous. Instead, they connect it to the power grid in the hangar. The clock is running now. The train is scheduled to be transporting passengers again in just 34 days. Project manager Dennis Sharamet is also on the lookout for internal problems. The onboard computer stores and reports technical errors, but not broken shelves, seats, or tables.
Now I'm checking the seats. They need to be easy to adjust.
Travelers can book the Sapsan in a total of 6 different classes. They can choose between Economy Class, Economy Plus, Dining Car including food, Business Class, and Premium Seat Class. A trip from St. Petersburg to Moscow costs between 60 and 280 euros. One highlight is the conference lounge in car number 1. Price about 500 euros. For that, you get a sofa, comfortable seats with tables, 3 of your own televisions, and dimmable lighting. So far, everything looks good. The only things worrying the project manager are the broken windows.
What's complicated is that the glass is glued in with a special material. To replace the window, you have to cut it out, clean it, prepare it, apply primer, put adhesive on it, and only then you can insert a new one.
While Dennis Sharamet continues his patrol, some 20 workers outside converge on the train and begin the dismantling process. They also clean the water tanks using a citric acid solution. The acid disinfects and decalcifies the tanks. Inside, work is already in full swing as well, just 1 hour after the train's arrival. The vacuum toilets are all removed. A workshop will completely overhaul them before workers reinstall them in the train. The kitchen is also on the agenda for the first day. If any of the appliances are broken, there will still be enough time to repair or replace them. Dennis Sharamet's team works through almost the entire night to make sure that they can divide the train tomorrow as planned. Day 2 of the mega pit stop. The 250-meter-long train will be split today, a premiere, because this Sapsan is the first train to ever need an R3 revision.
You have to take them both out. Everything's on schedule. We're preparing to divide the train. To do this, we will remove the cables and take out the bellow where the cars are connected.
Since the Sapsan has underfloor engines, several cable harnesses run under and between the cars. They are responsible for controlling the engines and brakes. Only once the technicians have detached these cables can they separate the train. Because the train is disconnected from the overhead line, a diesel locomotive is needed to shunt the 600-ton Sapsan. It pushes the entire train to the paint shop. Here, it is divided into 2 parts. The second half is taken to a track with a special lifting system. Project manager Dennis Sharamet has scheduled 1 hour for the shunting work. Everything is going according to plan for now. The train is in the paint shop. To divide it, workers first remove the bellow. The coupling is next.
A nut is causing problems. It won't budge.
This sapsan has been in operation for 9 years. Today, it's going to be divided for the first time. The problem is that rust and dirt have jammed the screw connection on the coupling, making it impossible to loosen. It is the first big challenge for Dennis Sharamet. His team can't carry on with their work until the train is divided. The super tight schedule is under threat.
If we move it now, it should come apart.
They got it. But thanks to the complications, the team has lost valuable time. The painters get right to work. Meanwhile, the diesel locomotive pushes the other half to the adjacent track. Here, there are special jacks that can lift the entire train half at once. The shunting work is complete by the early afternoon.
Да, сейчас все, слава богу, нормально.
I'm glad we're done with that. Fortunately, I planned in a bit of buffer, but I hope that kind of thing doesn't happen again.
Next step, replace the bogies. For this, the engineers have to lift the train half, all 125 meters and 340 tons of it. A critical moment. All 20 jacks have to be completely in sync with one another. Just 2 centimeters difference and the train could tip over. Only once the cars are at a height of 2 meters can the workers move the old bogies away and place the new ones underneath. Traveling at speeds of up to 250 kilometers an hour, the train is subjected to an incredible level of force. The bolts connecting the bogie and car body are 30 centimeters long and 3 centimeters thick. Workers now have to remove 10 of these bolts on each bogie. Workshop foreman Viktor Lipov is responsible for the lifting process. He meticulously controls the work of his mechanics. And he's highly aware of all the sensitive technology installed around the bogies. To save space in the cars, all mechanical and electrical components, such as transformers, compressors, and power converters, are installed under the car bodies. This leaves more space for seats in Sapsan trains.
If we forget a screw, it's very bad. It could cause things to break down, which could cost a lot of money.
Although the schedule is tight, the experienced workshop manager has plenty of time for the inspection. If anything goes wrong, he's the one responsible.
I've checked everything now. We can lift the train.
Lifting is handled by 20 jacks, each with a maximum capacity of 20 tons. The workers position them at special points under the car bodies.
If the jacks are not positioned precisely, the train could tip over and fall down, which is why we have to make sure the jacks are seated exactly.
Also important, all 20 jacks have to be completely in sync. They are connected by data cables and can be centrally controlled.
We're ready. Let's get started. Arthur, go to that bogey over there.
Even though the system is electronically controlled, Victor positions one worker at each jack. Better safe than sorry.
I'm a little nervous, but that's the way it has to be. I use it to control the jacks. Ready? Pasha? Everything okay?
In the first step, Victor lifts the train just a few centimeters. Then, his people check it again. There's a problem at the rear bogie.
The cross member won't come off.
I think we just need to go a little higher.
It has already come loose a little bit.
Look at the beam here, Pasha.
I'm going up another 3 centimeters.
Victor's plan? Keep lifting the train up, very carefully, and hope that the jam cross member will come loose on its own. And indeed, his plan works.
Sometimes parts get rusty and seize up, and this creates problems. Fortunately, everything is working again now. But I'm still going to take another look.
Now, Victor can lift the train to the final position. It takes him about 20 minutes to get it to a height of 2 meters.
We're done.
Now comes the next step, replacing the bogies. Victor Lipov and his team push the bogies out from under the train by hand. Despite their impressive weight of 11.2 tons, this is still the fastest method. Each bogie has covered approximately 1.2 million kilometers, equivalent to 30 orbits around the Earth. Most of it in freezing temperatures and snow, an extreme strain. Time for a general overhaul. In the paint shop next door, work is being carried out on the other half of the train. Kicked up stones and ice chunks have left countless dents in the Sapsan's aluminum skin. Workers will have to repair them first. They can't repaint the train until this work has been completed. The old bogies have since arrived in the workshop at the other end of the depot. Boss Mikhail Dubov and his team are responsible for the regular exchange of the Sapsan's bogies.
The brake shoes in particular have to be measured over and over again. We check them at every inspection and replace them when needed. The rubber parts suffer the most damage. They almost always have cuts or indentations, usually caused by chunks of ice in the winter.
Mikhail and his team check these wearing parts at every basic inspection and replace them as required. For the major R3 revision, they take the bogie apart completely. They start with the crossbeam on which the car body sits. The main part of one bogie, the frame, weighs almost 10 tons alone. Mikhail and his workers check the steel for cracks. They replace parts such as springs, brakes, dampers, stabilizers, and all screws, whether damaged or not.
The bogies hold the weight of the entire train. If something breaks or falls off, that's bad, and it can cause an accident. That's why we have to check this part very carefully and always replace the parts according to the maintenance schedule. In other words, before they can break.
It takes about a week for a bogie to be overhauled and reassembled. The wheel sets are sent to a different workshop. The stress on the wheels is particularly high when the train is in motion, especially on the running surfaces and the wheel flange, that is the raised side part that prevents the wheel from slipping off the rail. A special lathe brings the wheels back into shape. The lathe has to machine down about 4 millimeters of specially hardened steel to get rid of any unevenness and corrosion. The wheels still have to be put on the test bench. After that, they can be reinstalled. The maintenance team has an exchange system in place for the bogies. 10 fresh bogies are ready and waiting for the presently wheelless sapsan. After the overhaul, they'll use the newly removed ones for the next train. A time saving, to be sure.
It all looks good. Everything's okay.
The workers push the bogies under the train in a specific order. Workshop foreman Victor checks that each one ends up in the right place.
Every bogie has to be in a certain place. The cars have different axle loads, and therefore each bogie is calibrated differently. We're not allowed to swap them under any circumstances.
Some bogies have a motor, thus known as motor bogies. The ones without are called trailing bogies. This also plays an important role in distribution. By late afternoon, the work is complete. Next, the technicians reconnect the cars to the bogies. The greatest difficulty? The connecting bolts are located on the crossbeams, which have to be fitted precisely into the carriage frame, right down to the millimeter. This is why they initially lower the train to just above the bogies. With the aid of integrated air suspension, the bogies are pumped upwards for the last bit, where they engage. It's a complicated step, during which a lot can go wrong.
Everything looks good. So far, there have been no problems in the preparations for lowering. Now the workers are about to move into their positions, and then we can begin.
After the final preparations have been completed, workshop foreman Victor Lipov instructs his workers.
If there are any problems, don't call me first. First, press the emergency button and then call me. Is that clear? Great, then let's do it.
As with lifting, Victor Lipov positions one worker at each jack. Once again, the rule is to keep an eye on the car body and bogie and hit the emergency stop immediately if there are any problems.
Pasha, everything okay? I'm going ahead.
The first 1.5 meters go quickly. Then it gets tricky. The workshop foreman feels his way forward, millimeter by millimeter. If the connecting bolt does not slide exactly into the hole, it could get stuck. In the worst case, the team's only choice would be to destroy the bolt to release it again. Just before the bolts engage completely, Victor stops the jacks. Now, manual work is required for the final millimeters. The workers push each bolt individually into the corresponding hole. To do this, they pump up the air suspension on the bogies. They also lift each bogie with a wooden beam. It's a simple and effective method, but for this last step, it needs not just strength, but above all, feeling. Not possible with a machine.
That was the 10 millimeters we needed.
With this approach, the workers engage one bogie after the other.
It worked out well.
The paint shop is also making good progress. The workers are priming the last car from the other half of the train. Then they paint it and apply 2 coats of lacquer, a total of about 140 kilos of paint on each car. Day 15 of the mega pit stop. Around about the halfway mark, the first part of the train is almost finished. You can no longer tell that it's already traveled 3.7 million kilometers.
The paint work on this half is finished. They've done a good job. Now we can swap the 2 halves of the train. Right now we're still on schedule, which is really important to us. Despite the minor difficulties, we're halfway finished with the overhaul. But we still only have about 20 days until we have to return the train to the railway company.
The project manager now orders the train halves to be switched. The freshly painted section is placed on the jack track. The train half with the new bogies goes to the paint shop. The diesel locomotive is once again responsible for reparking. Dispatcher Alexander Filipov coordinates the shunting work.
The train has been stationary for more than 2 weeks now. It's possible that not everything will work right away, so we have to check everything again.
And they have to listen very carefully. The downtime during the mega pit stop could have caused the brakes or axles to become stuck. A squeak or rattling would immediately indicate to the specialist that something is wrong.
As we can hear, it is not making any strange noises when rolling.
The shunting work may seem cumbersome, but if you first painted the entire train and then replaced the bogies, the revision would take about 3 weeks longer. The train half with the new bogies now comes to the paint shop. After 30 minutes, it's in position.
The maneuvering went as planned. There were no problems. We're going to start painting right away.
The painters don't waste any time. They only have 3 days for each car for sanding, filling, priming, painting, and applying 2 coats of lacquer. At the same time, Viktor Lipov and his workers replace the bogies on the other half. The team works practically around the clock. Even after the exchange, there are still only 12 days left for all the work that has to be done. Day 31 of the mega pit stop. In 4 days, the team has to return the train to the railway company. In the meantime, the sapsan has been completely painted and the 2 halves have been coupled together again. But the work is far from finished. Now it's time for the pantographs on the roof. Above all, the so-called grinding strips are extremely susceptible to wear. They are made of soft copper with a graphite core. Friction on the catenary causes them to constantly wear down. At speeds of up to 250 kilometers an hour, the pantographs are also subjected to severe air turbulence. In the course of the major R3 revision, the team replaces them completely. The sapsan has a total of 4 pantographs. They all clearly exhibit the wear resulting from the many kilometers and the Russian climate. That is why the workers replace them all together. Each pantograph weighs 270 kilograms. The freshly serviced spare parts are ready and waiting. Also here, the system of exchange is the only way of meeting the tight maintenance schedule. While traveling, 3,000 volts flow into the train through the pantographs. Just one porous seal could lead to a short circuit and paralyze the train.
Accuracy is very important in this work, because without pantographs, the train cannot move. The old pantographs now come into the workshop where we check and repair them, and then we install them on the next train.
In addition, the workers replace all cables and insulators. While the work on the outside of the train is almost finished, there's still a lot to be done on the inside. Only 2.5 days left. Then the sapsan has to be ready for service again.
We've just checked the progress of the work, and at the moment, everything is going as planned. But there is not much time left, and there is still a lot of important work to be done. For example, we still have to check all the technical systems. I hope we have time to do it all.
And there are other jobs still to be done. The team has to replace the broken windows and check all 604 seats on the sapsan, and if necessary, repair them, as well as servicing the 2 drivers' cabs and checking the interior doors and electrical systems. Train technician Alexei Zaloshenkev is responsible for the broken windows. All the windows on the sapsan are almost 4 centimeters thick. They are made of 2 panes of laminated glass which makes them extremely safe. Even large flying stones can't get through.
These windows are different from the normal windows you're familiar with. And the frame is made of aluminum, which is why it's so hard to move.
What's more, the windows are fixed with an extra strong adhesive. It takes Alexei almost an hour to cut out the double pane. And he still has 9 more broken windows to deal with.
To get it out of the train, you have to hit it here. And the middle falls out and the edge stays in. That's why it splinters like this.
To remove the tension from the glass, Alexei smashes the window. This makes it easier to lift out. While Alexei's still struggling with the window, electrical technician Anton Smirnov is checking the fire alarm on the Sapsan. A special test spray simulates smoke.
Now I'm waiting to see if the alarm reacts. This bit is lighting up red. That means the fire alarm is working.
Each electrical cabinet in the train is equipped with at least one fire detector. This is where the danger of an unnoticed fire is most threatening. A total of 110 fire detectors are installed inside the Sapsan. To avoid panic, no alarm can be heard in the cars themselves.
This is the room for the conductor and the engineer. The fire alarms can only be heard in here. Here we can see there's a fire alarm in the passenger area. If there's ever a real emergency, the team can react immediately.
All fire alarms are working. Anton now heads to the seats in first class, together with a colleague. The adjustable luxury seats are full of all kinds of electronics.
Sometimes passengers accidentally pour coffee on this bit here, and the liquid causes the electronics to burn up. This is a major problem for us.
Anton and his colleague check all 104 electronically adjustable seats and repair them if necessary. All that in only 3 hours. Another team of technicians is working on the train's 22 automatic doors. The main focus of technician Igor Yarinov is the door's emergency stop.
I'm looking at the emergency switch. This rubber piece is there to make sure no one gets hurt. I'm checking if it works. And at the same time looking at the door mechanism.
Igor recalibrates the sensor on every door. Anton is now finished with the seats. Now he'll tackle the 2 drivers' cabs.
The first time I sat here, I thought it was pretty exciting.
The Sapsan's driver's cab is one of the most modern in the world. The onboard computer monitors all components on the train with the aid of sensors.
Now I'm erasing the fault memory. The work we've been doing has caused many malfunctions to be triggered. The computer controls the train and checks whether the faults have been corrected.
Здесь мы можем управлять системой поезда.
Everything's all right here. Now I just have to do a few little things and then we're done.
On the outside of the train, technician Alexei and his colleagues prepared to install the new windows. The special adhesive is UV resistant and transforms into an extremely durable rubber mass while drying. A Sapsan window weighs about 20 kilos.
Now the window has to dry for 24 hours. Then I can do the outer seals. We'll do all the other windows the same way.
The train has to be back in service in just 2 days. While the final work is being finished off, the train crew is also completing all the preparations for the passengers. Mega pit stop, day 33. Today, the final technical tests are taking place. For the train to travel quietly and above all safely, Viktor Lipov has to adjust the bogies to millimeter precision.
We've fine-tuned the train's bogies. Now, I have to make sure everything is correct.
For this, the train travels with each bogie individually on a special scale. It measures the wheel load on both sides. Only minimal deviations are permitted.
If I find a mistake now, we'll have to readjust everything. Stop! 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 And we'll probably have to postpone the test drive so we can correct the error beforehand.
That would be a major setback. The fact remains that the train is supposed to be in service the day after tomorrow.
We're done now. Everything's fine. The train is free to roll.
But there's one last milestone that's still missing: the test drive. The train is not allowed to take on any passengers until the test is complete, and it starts at 3 o'clock in the morning. Dennis Sheramet and his team can only know if they have done a good job when the train passes the test drive. Have they successfully mastered the first major R3 revision of a Sapsan? The test driver has had special training. Ultimately, he helps decide whether the train is allowed to return to active service or not. Test drive takes 6 hours. During this time, the Sapsan has to cover around 500 kilometers and perform various braking and driving maneuvers.
We have a test program, and we're working through it now. We've completely dismantled the train, and now we have to check whether everything is working properly.
After 34 days and 5,350 hours of work, the Sapsan rolls back onto the rails for the first time. On the open track, the first test, emergency braking. While traveling at 200 kilometers per hour, it has to stop within 1,600 meters.
Fantastic. Excellent.
Emergency braking worked without any problems. Next, Dennis and Victor check the bogies from the outside. For this, the train drives past them very slowly.
There can't be any noise, crunching, whistling, or squeaking while the train is moving.
If Dennis or Victor were to hear anything, it would be back to the workshop for the train. Indeed, the freshly serviced Sapsan passes this test as well.
Okay, let's go.
Let them know we're on board.
Sapsan drivers,
Sapsan 5, go ahead.
we're on board.
Okay, then we go up to the platform.
Now we will walk through the cars and listen again.
At full speed, Dennis and his team listen out for any strange noises inside the train.
I pay special attention to what the wheels sound like. You shouldn't hear anything but the sound of rolling. Then it's fine. If there are any other noises, it means we have a problem.
The train driver guides the Sapsan along the track at 200 kilometers an hour. Behind him, controllers continue their work.
Все хорошо.
Everything is fine.
Даже те звуковые
Even the sound I heard at the beginning in the 6th car is no longer there.
в вагоне в начале поездки сейчас уже практически отсутствуют.
That tells us it was most probably just the new wheels.
Вопрос был в обточке колесной пары.
They got it. Dennis Sharamet and his team have successfully mastered the very first R3 revision of a Sapsan. Now, the world's longest high-speed train is ready for the next passengers. In just a few hours, it will once again be transporting hundreds of them, with high speed from St. Petersburg to Moscow, until the next mega pit stop.